right, welcome everybody to Dave Cooper Live, where we showcase the people, the products, and the processes that are building it better. And today we are talking about low voltage power and building automation. Among many things, how does this energy efficient electrical system fit into housing affordability? Well, you're going to find out because we got Jim Baldwin on today to explain how DC power integration combined with data can deliver. As the CEO of Domatic, and with the goal to make every fixture intelligent, installation simple, we'll discuss why AC power is overkill and DC power is more energy efficient. They have partners like Cloud Apartments and Plant Prefab. So see how this team is amping up on affordable housing and smart building technologies. But first, we always got to thank our sponsors. So how about a big shout out to them, and we'll come right back with Jim. Stream Modular, the only logistics company you need to transport your mods, pods, and panels. Our friends at Stream Modular are investing $50 million over the next 25 years to build the technology, solutions, and trailers needed to handle and transport the projects of today and meet the demands of tomorrow. Reach out to their team at streammodular.com to discuss your next project. CombiLift is the largest global manufacturer of multi-directional forklifts and straddle carriers, a leader in long load handling solutions, offering a free warehouse and site optimization design service. CombiLift helps companies of all sizes and from every industry maximize the capacity, safety, and efficiency of their warehouse and storage facilities. A big thank you to Paul Short and the team at CombiLift for helping us all to build it better. Visit them at combilift.com. Brave Control Solutions, where offsite manufacturing systems that do more than just improve productivity. They have a unique approach to industrialized construction, a lineup of flexible automation systems specifically designed for the construction industry, empowered by CAD to Fab, and turnkey solutions for 3D volumetric assembly, structural insulated panels, finished wall assemblies, MEP component processing, assembly, kitting, and storage. Learn more at thinkbrave.com. All right. Once again, a big shout out to all of our sponsors. We cannot bring you all these informative conversations without them. So make sure you go out there and say thank you as well. All right. Who would have thought we could power our homes with low voltage? Can we? Is it proven? Are we doing it yet? Well, we're about to find out. Let's bring Jim onto the show. Jim, how you doing, my friend?
Howdy, Dave. Good to see you again.
Yeah, good to see you. Thanks for coming back on the show. You know, a while back we had this conversation. You had this awesome idea, and you were prototyping it, and you were working in some modular manufacturers. But now, I mean, the pavement has the tires have met the pavement and hit the road. You actually have some product that's out there functioning, collecting data, and all the fun stuff. But before we get into it, Jim, we want to know everything about you. We want to know all the things that you used to do before you came on the Dave Cooper Live show. In fact, we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or we will have your kids on the show. And I know it'll get embarrassing then. But you only got 2 minutes to do it, so give us a little update on who you are and where you come from.
Okay, the 2-minute version. I'm a Midwestern boy, grew up in Illinois, son of Midwestern parents. My dad worked at the John Deere tractor company his whole career. Came out to California after college to work at Apple Computer and started my career in tech. Oddly, Apple was a great place to start your career in tech because it was completely chaotic back then, which taught me how to just avoid, falling into ruts. So it's been my entire career has been about finding ways to make a difference and put a dent in the universe. So notably at Apple, I worked on a technology called FireWire, which was an interconnect that carried power and data on the same wire. And when you start looking at what we're doing now, you'll start to see that, perhaps this is a redux of what FireWire did for computers, we're now doing for the building industry. So did some time at a couple of different startups. One of them ended up bringing me to Microsoft. I built large, complex distributed computing systems mostly for television. If you ever used AT&T's Uverse television platform that was built by my team at Microsoft, did some more corporate gigs, running the digital home group at Intel, and decided that I really wanted to do was go do something new and from the ground up to really make a difference. So after a few years, found this idea of maybe we can take this concept of combining power and data into a simple way to wire up buildings into a real product that we can take to market. And that's how we got to build Dematic.
Love it. Love it. So, Jim, let's start off with the basics here, right? Can you explain the basics of low voltage house wiring and the significance that it has in a residential setting? And then I think we can hop into the presentation and a video, and we might even have a little more candy on top of that. Go for it.
Yeah. So basically, what's only really become feasible in the last 10 years to do this, but the electrical code has always had this opportunity called Class 2 power. And it was there from the inception of the code to allow the phone company to put a voltage on the wire to power your handset. That limit is 100 watts and 60 volts. So yeah, 10, 15 years ago, you could maybe put one light bulb on the end of a wire at 100 watts. And so it wasn't very meaningful to use for a general purpose power distribution. But with the advent of LEDs and DC motors are the two key technologies that have come about in the last 10 years that have made it so a significant amount of the fixtures that go in a building can now be powered on a low voltage profile. So what we looked at this and said, well, this is great, but how do you actually control it? How do you manage it? Because it's a real opportunity. You could certainly say, let's just run low voltage, let's still use switches and run, do things the old school way. But we said, what if we could make it a smart building at the same time? So what we came up with is this idea that voltage we put out to power those fixtures on a single cable with two conductors can actually modulate. And what we do is we wiggle that voltage, that 48 volts, you look in the oscilloscope is kind of bouncing around, and that's a way of communicating information. That information carries 100 megabit per second data signal that can now give every fixture in the building its own IP address, which means every fixture in the building is now smart and programmable and can become part of a smart building system, which opens up a whole set of opportunities around using software to innovate instead of having to stick with traditional ways of wiring and controlling buildings. So we saw this as an opportunity, because of, you never want to start a company without knowing why now. The why now is LEDs and low voltage really finally being possible. We said, here's how you do low voltage, because we're engineers, we can't help ourselves. We said, here's how we can solve this problem. Let's design some hardware and software to really make this possible. So
safety-wise, it's also a big safety factor, isn't it?
Yeah. And the reason the codes are relaxed for Class 2 power is because it is inherently safe from fire and shock hazards. You're not going to kill yourself or cause a fire on a 48 volt, 100 watt limited power bus.
Right. And before we get into your presentation on this too, just help me understand, what do you do when you have a air fryer or a microwave or a refrigerator? It can all be controlled through your system?
So we don't do the power for high voltage devices, and we're not really trying to be an appliance power system. We're not the outlet on the wall for you to plug your microwave into. We are the buildings network. So we power the built-in fixtures, all the components of the building, everything that's really permanently installed. But oddly enough, we can also supply the control plane for these things. So even like with HVAC, even though we don't power the HVAC unit that takes more than 100 watts, we actually supply an interface to the traditional BACnet or Modbus interfaces to it, so that HVAC system can become part of a modern control plane that we run on top of our network. So yeah, we're not trying to do your microwave. That's a whole different scope, and if we took on everything at once, we'd probably not do it all very well.
Right. For sure. And then my last question, and you're probably going to jump in this, and I'm probably jumping the gun, but how do you convert the power coming into the house? Because right now it's not coming in as low voltage.
Right. So typically in a lot of our installations, we're getting one 120 volt circuit fed to us, and we do a simple power conversion with off-the-shelf AC/DC converters. And at that point in time, That power goes to our hub, which is this device that gets mounted usually in a low voltage cabinet. Here's the new version of our hub we're working on. This guy has a power input here, a backbone for network connectivity, so we can be part of the building network. And then each of the ports here on the right side is a 100-watt class 2 power source. And we get a UL sticker on the hub because we proved to UL testing that this is meets class 2 limits. So this is a point where the power goes from AC or DC to DC at 48 volts, and then it gets distributed around the building at officially low voltage from our hub on down.
Yeah. Cool. Well, let's hop into this because I want to get into cost savings. I want to understand, the value of this system over how we've been doing it. And then, of course, the cost of installation now that you're up and running all over the place. But let's get through your presentation. I'm going to follow your lead. Let's walk through this, and then we'll get to some questions here at the end. Sound good?
Sure.
Excellent.
So actually, I think let's show I'm gonna talk a bit about this project we just finished, but maybe we can bounce back to this slide after we show the video, because I like people to see the building that we built here. Maybe we can narrate it a little bit while it plays.
You want me to? I'll kill the sound.
Yeah, go ahead and play the video. Yeah. So this is the Downtown Emergency Service Center in Seattle. It is a supportive housing project, which means it's a building built to help get homeless people and the most vulnerable in society off the street. So it's 124 apartment units, and it is operated by an organization that is there to take care of people in society. We powered everything in this building that can possibly be powered on a low voltage profile. So all the lighting, the sensors, controls. I'll go through the laundry list in a second, but it's a magnificent project. It's a panelized structure originally designed and built by a company called SLI that is a separate story. They're not around anymore, but the building is DC powered with a Corning intelligent power system feeding us power at our hubs. There's a fiber distribution network for our connectivity. You'd be surprised at how smart it is to use fiber in a building to distribute, because you just have a lot less stuff to pull to set up your networking. So here you see the bathroom in one of the units. This is a rugged environment. This buyer did not want necessarily a lot of fancy smart home features. What they really wanted was to know when something is broken so they can fix it. So a lot of the emphasis, what we did here was around, operability and maintenance of the building. But in the process, we were able to set everything up automatically without a lot of installation pain.
Wow. And that's a big building. So what, when you have a building like that and you set it up to do all these wonderful things that you're talking about, walk me through some of the key points of why the consumer wanted the data, right? Because we're looking at an affordable project. We're looking at a project maybe with some troubled people in it or what have you, right? Mm-hmm. So having something that is, I guess, can take wear and tear is one thing, but also knowing the data behind each room, each light, each water valve is super important as well.
Yeah, exactly. And the impact of not knowing that water is free flowing in a unit for an hour when it shouldn't be is meaningful. So our system is constantly monitoring all the sensors. We have a feed of events that come out of the building that covers just about everything that could possibly happen in the building, and that includes excess use of power or water, as well as even the occupancy sensors that tell us that there is or is not movement in the building can be an indicator of problems that they want to pay attention to. So I don't know if you want to pop back to that slide. I can go over some of the things that really set this building apart. So as I said, there are 124 dwelling units fed by that all DC power system. There's also solar on the roof. There's a whole effort to get to net zero energy that going on with these buildings. There are 1,500 plus Dematic enabled fixtures in this building, all being monitored by our system. The really cool thing is when we set up the building, Obviously going through 1,500 devices one at a time would be insane, which is kind of how modern automation systems work. So we built a system that is templatized, an auto provisioning system where we basically automatically recognize every fixture in the building without any human intervention. And then the only thing we had to do with the install team was we provided a little phone app that let them go into a unit and disambiguate the switches. That was the only thing we couldn't identify automatically. The lights, while the lights all looked the same from a physical perspective, they all had different power consumption. So we were able to identify disambiguate the living room, kitchen, and bathroom lights in these units because they use different amounts of power. So there's really some creative stuff you can do when the system is automatically, connects to these devices. You can talk to these devices, query them for what's going on. And we limited the amount of provisioning work to simply identifying the light switches and which circuits they were on. The building, like many buildings, you have to have emergency egress lighting. So when Seattle Light and Power goes down, the building switches over to emergency backup power, and our system reconfigures for minimum lighting during egress mode to make sure that the pathways are lit for safety purposes. We do daylight harvesting. That was a city requirement that when the sun is out and you're getting light from the sun, which does occasionally happen in Seattle, we dim the lights to take advantage of the daylight that's already coming into the building. We do occupancy sensing throughout, so we can shut lights off when things aren't working. As I mentioned before, we're doing water submetering and power submetering. We're not billing these tenants, but we're providing this as a means of letting the building operator know how the building is performing. In the operations center, they were required, similar to the daylight harvesting requirements, we had to do controllable outlets. So we basically were able to put a simple Dematic device on a relay that allowed us to control outlets. And voila, we've covered what in California we call Title 24. In Seattle, they've got a different term for it, but we're able to meet that requirement. And then, like I said, everything is online. So when something goes wrong, I get a notification and the building operator gets a notification, let him know the severity of the situation and what needs to be done. And you don't have to sit around and wait for somebody to call you up and say, hey, something's not working. You know ahead of time, because we literally can measure the amount of voltage and current every device is using in the system, which is unprecedented. That's really never been done before.
So if a light bulb goes out, you'll know it.
Yep.
And you'll know exactly where it is. And then we'll contact an admin right away.
Yep. It goes straight to the faults and notification system, and they can take action on it. And as part of our SLA for the building, we support the cloud website as well as help people debug problems. So we're really all in the idea that operations is improved, and we're investing heavily in making sure that the OpEx can be reduced.
Sure. So here's some photos, some of which we just saw in the video. So all the hallway lighting there is obviously all done low voltage.
Mm-hmm.
Looks like they have some reflective material in the hallway as well to add some extra light reflection, or maybe it's just a high use material to be able to use.
It's a rugged environment, so they have some pretty robust materials. Obviously, solar on the roof.
Yep.
You see one of our light switches on the lower left there. We built our own custom light switch just to show how simple it can be to make a device that connects to Dematic. Mm-hmm. In the lower right, you see our hub. That's the 8-port version of our hub. I showed you just now the 10-port version we're doing now. That's made some improvements on it. And then in the courtyard there, all the lighting outside there is also on low voltage system. So we literally, there isn't a single photon in the building that is coming directly from an AC source.
That hub that you have there, Jim, we were talking about little modules that you can put on outlets or fire alarms, whatever the case is. Is that all built inside that module you have right there? Or do you have to put other pieces elsewhere?
Yeah, so the hub is a point of distribution for power. If you think of it, the moral equivalent of USB in our world is that 2-wire power coming out of the hub. These connectors plug straight into the hub, carrying 48 volts and that modulated data signal. So on the other end, we put a variety of different devices. So you saw one of our switches, which has a really nice field to it, and an indicator along the side to tell you what the state of the circuit is. We have a number of different driver devices that have a plug for the 48 volt input, and then a plug for whatever the functionality is for the fixture that's interfacing to. We've got some that do constant current light fixtures, some that can work with constant voltage fixtures, as well as a variety of different sensors and things like that. We've got some new devices underway. We've been thinking a lot about the form factor. So this is our new constant current driver. This is basically it's a 1.75 by 3/4 by 3.5 inch, I think is what the dimensions are. This is designed to fit inside a fire safe ceiling box, so you can tuck it away and not have to find a place to stick the driver. We've been spending a lot of time with our customers thinking about the deployment and how we streamline things. So there is some kind of adapter somewhere to convert the 48 volts to whatever the fixture actually needs. And in that process, we're actually not just converting the power, we're actually doing interesting things like dimming. So when this device takes in 48 volts and converts it to a constant current, either this or this, the two generations of the same thing, that constant current output is controlled by the driver. So effectively, the dimming of the light is happening inside this driver. It's how bright the light is. And the other interesting thing is there are two outputs on this guy. We can control color controllable light with this just as easily. It's a freebie to us to do to be able to shift the color temperature of lighting from warm to cool throughout the day, which effectively creates the concept of circadian lighting. And for us, it was zero added cost. We can, you don't have to have any kind of hardwire control mechanism for it. Simply, you can write software that decides when the color temperature is going to be warm or cool, and we do that by knowing what time of day it is and when sunrise and sunset are where you are. So we build a variety of endpoint adapters to turn off-the-shelf fixtures into Dematic fixtures.
Oh, cool. Very cool. Very cool. Let's keep walking through here. What do we got here?
So we've got a project going on with plant prefab and cloud apartments. So we started working with cloud apartments last year. They built the Cloud S module in a factory in Richmond, California. Cloud is a really great, really forward-thinking company that sees the opportunity to take modular construction processes and build a luxury feel to an apartment building without the luxury cost. And so we built an entire prototype with them. They called it the Cloud S, the original studio module. And that's, anybody can go see that in Richmond, California if they want to. The Cloud S1 is the 1-bedroom apartment module they are building at the Tejon Ranch factory at Plant Prefab. And it is basically the last step before they go to commercial deployment. They're looking at multiple projects around California, from LA to San Jose, with hundreds and hundreds of units being built on this architecture. Our scope there is very different from the scope we just did for the DESC project in Seattle. Obviously we're doing lighting, we're doing ventilation fans. We're also doing door access controls. It's super easy just to hook up door strikes and keypads to our system. So we're doing, we'll be able to let tenants use their iPhones to unlock their doors. We do HVAC controls. We have, we can power on our system built-in ceiling speakers. So these apartments will have speakers in them. And when you move into the apartment, day one, before you even set up your internet connection, you can play music from your phone on your apartment. What a great way to welcome people to a new apartment than to let them, have a little party with music. We're doing motorized window blinds with the system. Window blinds are also a great candidate for low voltage. They all live within that 100-watt, 60-volt limit. Flood sensors and shut-off valves, so that when something does go wrong, they can shut off the water automatically to prevent a flood. Occupancy sensing throughout. And then what's really cool about Cloud, they really wanted to have a console for interfacing, allowing the tenant interface with the building. So we have a variety of different touchscreens we've done integration with, where basically a device like this, one of these two different touchscreens, can be mounted on the wall and express an application that is hosted by our hub. So this is, again, just a Dematic device. It just takes in 48 volts and presents an interface which is technically it's like a little web browser that can only run one website. That's kind of how we architect these things. But in Cloud's case, they wanted something really impressive. So they're using a 17-inch touchscreen that you see when you walk into the building. So it's like, I don't know, it's like you're living in a Tesla or something like that. But it's really cool. And the new app they're building for it to run on the platform is just out of this world. It's very, very, very cool what these guys are doing. So like I said, we went from just robust, making sure that the place is not being destroyed, to showing people what modern living should be like. Again, all on the same platform, all low voltage. No silos between different systems, which is really why this is interesting. There's no difference between the HVAC system and the window blind controls and the lighting and the door access, all one platform. And we can write software on the hub that can talk to all those together. So you can make, you can build experiences that respond to somebody opening their door, right, to turn the heat on or open the window blinds automatically. All that stuff can be done. Whereas in the old days with siloed systems, it just wouldn't be worth the trouble to try to do that integration. You would just, it'd just be so costly that you'd never even try.
So you said Cloud Apartments is writing their own app. You don't have an app, is what I'm hearing. You have the proprietary software, and people can build their own apps to integrate with it, or does this live on somebody's cell phone as well?
So we do build apps. We have a variety of apps we build for different purposes, and certainly white labeling apps that we build is an option for anybody that works with us, so they don't have to go invest in their own app development team. In the case of Cloud, they really felt they wanted to take that to the next level, so they're building an app team to develop an application. And in that case, we host the app, we supply APIs to make it really easy to integrate with us. We're not trying to be the entire stack anyway, and like we see what we're doing as an open standard that will eventually be how all low voltage power works. We don't want to get in the way of any innovation. So we'll be working with people that want to do their own applications. We'll work with people that want to do their own drivers. We're happy to take these designs that we put into these driver devices and offer them up for very, very favorable licensing terms to make sure that the ecosystem can be built out. And the last thing you want to do is try to own everything, because then you'll end up owning nothing.
So what are we looking at here? Remo Homes.
Yeah, so this is fun. This summer, Remo Homes built their first module and exhibited it at the nation's capital at the Innovative Housing Showcase, and that module was powered by the Dometic system as well. So through a great example of these guys are out to build prefab, advanced zero carbon homes, and really targeting the disadvantaged communities in California. They've recently won a grant, the California CEC, to build a set of units for I think it's for tribal housing. And these guys are, I'm sure you've met them. I was
in that down there when we were on. I was in that facility.
They are a ton of fun to work with, and we had a great time putting that project together. And I'm really having a little, and when you build something new like this, you end up finding yourself working with the craziest, most innovative people out there. And these guys fit that bill. They're you don't work with the laggards or the late adopters. You find early adopters and innovators all over the place, and Remo fits that bill.
Reframe Systems. Here's another one that you guys are using your product.
Yeah, Reframe is great. All in on robotics, and they're methodically building a system for building low cost housing using heavy investment in robotics. So we are powering their first prototype. You see some pictures here of it just starting to come together, but we are we're supplying components to them, and they're impressive. They start what I see in them is somebody who understands what it's going to take to build a robotic factory, and I think that they've got a really good shot at it, given the investment they're making.
Now, using your system, is it saving them power and energy with the robots? Is that what I'm hearing? Like, where's the energy savings for them in this manufacturing?
Well, the energy savings really is about operations. We save we save energy versus traditional systems, for two reasons. One is DC power is a little bit more efficient.
Right.
The conversion power to go from, when we go from 48 volts to the voltage needed by the fixtures in our devices, we're at 93% efficiency throughout the system. Whereas a typical AC/DC adapter off the shelf would be about 50-60% efficient. It's really a remarkable difference because the converting power from AC to DC takes some big components that simply are going to be more costly and more energy inefficient. So some of that there. So there's maybe a 20-30% improvement in efficiency. But the truth is, a smart building can respond to behaviors that allow us to make much better use of energy. And the typical estimate is that we save something like between 30 and 60 additional percentage on top of it, just being smart about turning things off when they're not needed. So if you respond to occupancy or, like things like daylight harvesting are just like, they've been left on the table for so many years because we didn't have the intelligence in the system to respond to that. So by building a smart building, you get significant savings in energy over time.
So let's get into design here. Are there any specifics that one needs to consider when designing low voltage systems into, homes or for upgrading their house? Like where does somebody start if they want to do this?
So if you want to use our system, there's one rule the MEP team has to understand, and that's we're a class 2 system. So they don't have to think about anything else. They just, being class 2 system, they know that each port on our hub here, when, this hub is basically with 10 ports is a 1,000-watt device, which means each port has to be 100 watts or less to meet class 2. And that's, we do that intentionally so that we can call it a class 2 system. Theoretically, we could put Dematic on a higher power system. We just don't think that brings as much advantage as taking advantage of the low voltage nature. So the MEP engineers that we work with on these projects simply design the system to make sure you partition the fixtures to not exceed 100 watts for any region of the building. So you'll take a cluster of fixtures and run a wire to them, branch it out to power up to 100 watts worth of fixtures, and then the next cluster will be on a different port on our hub. It's really super simple. What's cool is you don't have to do things like three-way runners or switch legs. I mean, the world of powering having to decide that your switches on the walls are going to have specific roles once the building is finished is over. Like we literally put a bank of switches in the wall with one wire coming to that entire bank. And those switches can do anything in our system because the control is actually just communication on the switch. This switch here is kind of like a keyboard. It's not, there's no triac dimmer in here. There's no power being made or, connected or not connected.
Right.
When you tap the button here, a message gets sent out that says up was tapped. And then the software in our hub says, okay, when you tapped up on this, here's what happens. And with that, you can do anything, and you stop pulling extra wire to places where you don't need it. So all the MEP team has to think about is getting power to all the fixtures and don't exceed 100 watts. Everything else is in the domain of software that happens on our platform.
Got it. Are there any regulatory factors that might influence the adoption of low voltage wiring in affordable housing or just anywhere? Because, California and Washington State are two different animals compared to Pennsylvania, Mississippi, and Louisiana. You know what I mean?
Well, most of it's to our advantage. I mean, from a regulatory perspective, everybody's all in on energy savings. There's a lot of governmental focus on bringing saving power and electrifying everything. We're very compatible with all that. We're being energy efficient, being simple to install. There's not a lot of regulatory headwind. Being class 2, it's safer. It reduces the overhead of inspections. There aren't a lot of headwinds from a regulatory perspective. If anything, they're all bringing benefit to our approach.
Sure. How about expansion in the future? Is the system going to be scalable? You think the trend's going to keep going low voltage, or are you already starting to see other emerging trends out there?
I think our system works wherever power is needed. We are if you think about, when you start a new thing like this, you have to think about where you start. You can't just go everywhere all at once. You're just gonna,
Right.
you'll die on that hill, right? So we have found, multifamily housing, hotels, that kind of infrastructure as kind of our sweet spot. That doesn't mean that we can't also do other types of buildings. In fact, we have a stick built, 40 unit apartment we're starting work on in San Francisco in a few months. We've got commercial properties we're working on. There's really no reason why you have to think of it just as a residential system either. But so our starting point has been this idea of just building better housing, and housing is the one thing we just desperately need a lot of. We don't need a lot more office space right now. I don't know if you've noticed, but there's a definite reduction in the amount of office space being created, but
Right.
housing will continue to be important. But beyond that, there's no reason why these approaches don't apply to just about any type of building in any region of the world. We've got significant interest from Europe and Japan. In fact, I just had 3 Japanese builders come visit me in my little office in San Mateo, talking about how we could expand into Japan. And the only thing I'm holding back on is I don't want to do that until I can do it right. So
Right.
we're now starting to think about what kind of partnerships we can build there. So there's really no limit to how far you can take this concept. I do think that one thing that will happen as we prove that that it set aside the low voltage piece, the smart building piece. This is a viable way to do smart buildings. We're gonna start building more and more high power smart building systems that there's no reason to limit. If you're willing to commit to it being a class 1 power system, you can do higher power on our system. So we're looking at a 1 kilowatt 48 volt system. We're doing a project with Lawrence Berkeley National Labs right now to experiment with DC power grids and using software as a means to negotiate, what the price of power is and who gets to use it and things like that. So there's a really cool academic component to that. But in the process, we're building something that can be taken to regions of the world where that class 2 limit isn't as meaningful. Japan is one of them. In Japan, you almost can't get away with anything that's called low voltage without, you still have to have do all the same work. So they're thinking, well, why don't we just go to a higher power version of this? So we're looking at partnerships to build out a high power version of Dematic. So the core thing we think is important is that those 2 wires that you're already running to a fixture to carry power to it should carry a data signal, and it should be a standard data signal. So you have plug and play capability, just like USB does for your webcam on your computer. I think you would never expect to have to configure your computer to tell what port your webcam is connected to. You shouldn't have to do that with your buildings either.
All right, everybody, listen, if you are just joining us, I have Jim on from Domatic, and we're talking about low voltage wiring. We're going to get to some comments here and a question here in just a moment. But just know, the International Builders Show is coming up. NAHB, that's right, Las Vegas, Nevada. And we're going to be giving away free tickets. That's right. Free tickets and giveaways all of February starting this Wednesday. So make sure you tune in. You might be able to get your free Expo Pass. You might be able to get your free Expo Pass with education sessions. They're not cheap, but you might get it cheap here on Dave Cooper Live and for free. And on top of that, we have the chair, Alicia Huey, coming on this show February 15th. So mark your calendars. It's going to be awesome. All right, Jim, we're getting low on time here. Why don't we go to a couple comments and a question, and then hopefully we can wrap up with the affordability side of installation and what you're seeing there. So let's see. We got Steve Dubin. Hey, Steve. I'll be there, Dave. Looking forward to seeing you. Awesome. I look forward to seeing you guys as well at the International Builders Show. Hey, there you go. There's the past chair of the National Association of Home Builders. The use of data helps Domatic battle housing affordability. Real cutting-edge use of power. Thanks, Jim, and great job, DC Live. Well, we always appreciate you tuning in. Greg, we know how busy you are running the political rounds down in Washington, D.C. and everywhere else. And then there's Henry Mickelberg from across the pond. He said, to get my head around this value prop, I can imagine that there might be a case to have just one AC/DC transformer to allow LOT, Class 2 LOT monitoring without multiple transformers, but we would still need LOT for anything 100 plus watt. Do you have any value prop examples of how this pans out financially? Great question.
Absolutely. Great question. So where we don't supply power, we still supply communication. So we have a device that, it's a little box about this size that has a pneumatic bus on one side and interfaces with an HVAC unit on the other. If you think about HVAC control today, it's kind of all inside this thermostat on the wall that sets the temperature and lets you interact with it and runs the algorithm and controls the HVAC directly. Well, it's not all that great to have only one point in the building where you're measuring temperature. If you really want to have a good algorithm for comfort, you want to know the temperature throughout the building. So what we do is we actually break it down where while the HVAC unit itself needs to get high wattage power, we provide the interface to it so it becomes a node on our network, as well as the sensors that measure temperature and humidity throughout the building, and the little touch screen on the wall that can let the occupant set temperature. Those become the components of a sort of a distributed thermostat system. So the way we look at that is we are the IoT system that plugs all these things together, whether they are low voltage or not. When they can be low voltage, we're also supplying power to them. That's probably the right way to look at it.
Awesome. IoT. I said LOT, didn't I? See, that's what happens when I read too fast. Well, the Internet of Things. I didn't get it. You got to do a capital L, Henry. I'm blaming you on that one. You got me all sidetracked. No, it's good. Appreciate the question, my friend. Look at that. We got Arthrado in the house. I just had a conversation about you guys today. Hey, Dave, it's Doug Hayden. Am I correct that a licensed electrician is not required to wire or install low voltage systems?
My answer to that is, possibly, but I think the real cool thing about our system is anybody can do it. And rather than thinking of it as you have the electrician come and do the high voltage and kick them out and then bring in a low voltage team, in a way, the electricians can do what we do as well. So there's no reason why an electrician can't wire up the pneumatic stuff as well, because we're not asking the install team to understand anything about internet technology. We are simply saying install the stuff, it's plug and play, and it works. The only technology they might have to interface with would be a phone app that would tell them if anything's miswired. That's literally it. So yeah, sure. I've heard people say, well, you can use lower rate technicians to do the install. I'm like, I don't know about that. I think it's great. It'd be great if we just empowered electricians to do more with less, with less of their time. Right. I think they can become smart building builders.
Awesome. Jim, anything that we left out today that you want to make sure you get across to everybody?
I think, to me, what's going on with Dematic this year is we have now, if anybody who's ever thought that we couldn't power a significant building, that it's proven now that we can. We are now moving into a phase of scaling out the system. It's, operating at 1,500 devices that have been online for 3 months now is just, we've shown that the approach we're taking does work, and there's no reason to be concerned about it. We've solved, any hiccups along the way, we figured them out, and now we've got a robust system that can scale up.
Excellent. Hey, and look at that. Andrew Seeley's out there. He says he loves the topic. Glad to see Jim on again. DC has real legs. Thank you, my good friend, Andrew Seeley. And if you're not familiar with what he's doing, you should check out his stuff. He's doing powerhouse distribution centers that are mobile everywhere. I love it. Hey, Jim, thanks so much for joining us on the show today. It's been an honor to have you back. And I can tell you one thing that really has me excited, and that is your success. I think this is super cool. You've been at it for quite a few years now, and you're proving the naysayers wrong and making it happen, and people are paying attention, and that's got to be pretty cool. It's got to feel good, right?
It sure does. Really appreciate that, Dave.
Yeah, for sure. All right, and for the rest of you out there, we'll see you this Wednesday for our product spotlight. And remember, all of February, we are giving away product passes, big passes, to the International Builders Show coming up at the end of February. So stay tuned, and don't forget to join us on the 15th. That's right. New chairs coming on. Alicia, you want to be there. You want to see it. You want to be square. Hey, Hey, Jim, don't go anywhere. I'm going to come right back to you after the outro. But with that said, make sure you thank these sponsors as well. I'm Dave Cooper. Thanks for watching. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.